Alarm clock. We need to get all the functionality, so after the first alarm, I'm going to turn it off and I'm going to set the time, okay? That's our Bluetooth dongle.
No. When they're little kids, it's banging, but if they're teenagers,
Maybe show this while you're waiting.
That's extreme. Like if he's being like if he brings home like cocaine, beating the shit out of him.
And the alarm's going off.
Tonight, I'm gonna have myself a real good time.
Not gonna get copyrighted on YouTube.
And now we're about to snooze. And as you can see, the snooze indicator is on. So we are going to wait a single minute. At which, oh, and I'm going to change the song as well.
Snooze using the phone this time. So if we press a button on the phone, by Bluetooth it'll mute it.
And as you can see, we just snoozed via Bluetooth thanks to our fancy Arduino. Now I'm going to turn this off, and I'm going to set a new time. So I'm going to go into time set mode. What time should I set it to?
7:32
p.m.
Oh. Sorry. $7:32?
Yep.
You guys really like 32 as a number.
34 then.
PM?
Yeah.
Yes. Can I see that in 24 hours?
Not yet.
Set it first. Okay.
Now I can show you in 24 hours.
Sure.
1934
And now we're going to set the alarm.
to 7:36.
Actually, no, sorry. We're going to set the date first. So, I'm going to go setting the date. I'm going to go, what date should we set it to? What is the current date today?
28:07.
Okay.
2016.
'07. Setting that date. I can display the date now. As we can see, the date has now been set. I can display this in 24 hours. And now I'm going to set the alarm. So, oh, sorry. What time is it?
7:34.
7:34, so let's go with 7:36. PM?
Yes.
Yes.
Setting. So now the alarm time is at that correct time. We're waiting a single minute. And did I cycle the song yet?
Quite closer.
Okay. We should have got that song that has the chorus, the waiting is the hardest part.
Yeah, I would have gone for that.
Waiting a full minute.
There we go.
And then we can, by
Not yet.
Bluetooth, snooze it.
And of course you can do it now. Snooze. And we've snoozed. And now, just because it's a video and you won't be able to hear the difference, going for that. So now we're waiting a full minute again.
To the last and final song. Would you like to show the guts after, Noah?
What? Yeah, sure, we can show the guts afterward.
Show the guts. Show the max volume it can go up for 5 seconds.
Snooze.
It's all good. It would literally destroy your mic. Okay, now we've done the full functionality test, so it's time.
Unplug it first.
I'm turning off the alarm first. So unplugging this. Now unplugging. So now we can go show the guts.
We used tape instead of screws because we couldn't find screws in time.
Sacrifices needed to be made. So as you can see, we got a lot of wires. We got a USB. Got some janky tape holding that because there was an add-on. Got our STM board with our shield. Our speaker here. Our buttons. Our potentiometer knob. Should we show them the shield as well?
Oh yeah. Well, on here.
Okay.
Don't move it. Just show them.
No, I know. Just you need to.
That's the STM board.
We have to slowly pry this off because, well, you don't want to break shit. Designed to fit quite tightly, quite snugly. There we go. And here you can see our shield. It's got both made by Osh Park, so it's got some nice purple PCB. And we got our header bank here. Got some pins on the other side. There's an audio circuit with second order band pass filter for the audio with an LM38 made with an LM385 and an LM386, sorry, which is an audio amplifier. That circuit is powered by this 9-volt battery, which is being switched by this transistor and this P-channel MOSFET from the STM. Then we also have a bunch of transistors here, which control the multiplexing for the digits on the 7-second display that you saw earlier. And we also have a bunch of push-button circuits, as you can see. So,
simple basic RC.
Yep, basic RC debouncing. Also debouncing hardware just to make it just make the push buttons more user-friendly. But basically debouncing in hardware to remove the ripple, and then debouncing in software to set the amount of time for the user interface for the button push. And that's our shield.
Shows the other side.
And then the other side, what we saw it earlier, but basically
just a bunch of
wires. There we go. And now I'm going to put it back together. Oh, there.
Inside we have the battery slots.
Battery slots in right here. Like so. You're going to remove it. It was outside just for the test, but then if we put everything back together, we stick the shield back on. Like that. There we go. And replacing it back in. Like so. Uh-oh. Tape fell out. Meanwhile, over here, we have an Arduino Uno, well, a clone of one, at least, with a, what's the name of the Bluetooth dongle? Reppin' hard the brands, man.
Blue Smurf or something like that.
Some Blue Smurf hard Bluetooth thing. Basically that's simply soldered and connected there, and you can see it was interfaced with the board over, because the STM pins are 5 volt tolerant. So that's how that works as well. And then of course, they're not currently powered by external power sources, so I have to power them from the computer, but that could be a next step. Okay, and that was our presentation.